Solid design principles in C# are basic design principles. In object-oriented programming, SOLID is an acronym for the 5 design principles introduced by Robert C. Martin. These principles are used to design software applications maintainable and testable. SOLID stands for Single Responsibility Principle, SRP. Open-Closed Principle, OSP. Liskov Substitution Principle, LSP. Interface Segregation Principle, ISP. And Dependency Inversion Principle, DIP. Single Responsibility Principle. SRP says, every software module should have only one reason to change. This means that every class or similar structure in your code should have only one job. Everything in that class should be related to a single purpose. It does not mean that your classes should only contain one method or property. There may be many members as long as they relate to a single responsibility. The single responsibility principle gives us a good way of identifying classes at the design phase of an application, and it makes you think of all the ways a class can change. However, a good separation of responsibilities is done only when we have the full picture of how the application should work. Open/closed principle. Open/clocked principle states that software entities, classes, modules, functions, etc., should be open for extension, but closed for modification. Now, what does it mean by extension and modification? Here, the extension means adding new features to the system without modifying that system. The plugin systems are the main example of OCP where new features are added using new features without modifying the existing ones. Basically, we should strive to write a code that doesn't require modification every time a customer changes its request. Providing such a solution where we can extend the behavior of a class, with that additional customer's request, and not modify that class, should be our goal most of the time. The advantage of OCP is that it minimizes program risk when you add new uses for an entity. Instead of reworking the base class to fit a work-in-progress feature, you create a derived class separate from the classes currently present throughout the program. We can then work on this unique derived class, confident that any changes we make to it will not affect the parent or any other derived class. You should not edit the code of a method, bug fixes are okay, instead you should use polymorphism or other techniques to change what it does. Adding new functionality by writing new code. In C#, open/closed principle can be applied using the following approaches. 1. Using function parameters. 2. Using extension methods. 3. Using classes, abstract class or interface-based inheritance. 4. Generics. 5. Composition and dependency injection. Liskov Substitution Principle. The Liskov Substitution Principle, LSP, is a specific definition of a subtyping relation created by Barbara Liskov and Jeanette Wing. The principle says that any class must be directly replaceable by any of its subclasses without error. In other words, each subclass must maintain all behavior from the base class along with any new behaviors unique to the subclass. The child class must be able to process all the same requests and complete all the same tasks as its parent class. In practice, programmers tend to develop classes based on behavior and grow behavioral capabilities as the class becomes more specific. The advantage of LSP is that it speeds up the development of new subclasses as all subclasses of the same type share a consistent use. You can trust that all newly created subclasses will work with the existing code. If you decide that you need a new subclass, you can create it without reworking the existing code. Interface Segregation Principle, ISP. Many client-specific interfaces are better than one general-purpose interface. Robert C. Martin. The Interface Segregation Principle, ISP, requires that classes only be able to perform behaviors that are useful to achieve its end functionality. In other words, classes do not include behaviors they do not use. This relates to our first solid principle in that together these two principles strip a class of all variables, methods, or behaviors that do not directly contribute to their role. Methods must contribute to the end goal in their entirety. Any unused part of the method should be removed or split into a separate method. The advantage of ISP is that it splits large methods into smaller, more specific methods. This makes the program easier to debug for 3 reasons. 1. There is less code carried between classes. Less code means fewer bugs. 2. A single method is responsible for a smaller variety of behaviors. If there is a problem with a behavior, you only need to look over the smaller methods. 3. If a general method with multiple behaviors is passed to a class that doesn't support all behaviors, such as calling for a property that the class doesn't have, there will be a bug if the class tries to use the unsupported behavior. Dependency Inversion Principle. One should depend upon abstractions, not concretions. Robert C. Martin. The Dependency Inversion Principle, DIP, has two parts. 1. High-level modules should not depend on low-level modules. Instead, both should depend on abstractions, interfaces. 2. Abstractions should not depend on details. Details, like concrete implementations, should depend on abstractions. The first part of this principle reverses traditional OOP software design. Without DIP, programmers often construct programs to have high-level, less detail, more abstract, components explicitly connected with low-level, specific, components to complete tasks. DIP decouples high and low-level components and instead connects both to abstractions. High and low-level components can still benefit from each other, but a change in one should not directly break the other. The advantage of this part of DIP is that decoupled programs require less work to change. Webs of dependencies across your program mean that a single change can affect many separate parts. The second part can be thought of as the abstraction is not affected if the details are changed. The abstraction is the user-facing part of the program. The details are the specific behind-the-scenes implementations that cause program behavior visible to the user. In a DIP program, we could fully overhaul the behind-the-scenes implementation of how the program achieves its behavior without the user's knowledge. The reason behind most unsuccessful applications. Developers build applications with good and tidy designs using their knowledge and experience. But over time, applications might develop bugs. The application design must be altered for every change request or new feature request. After some time, we might need to put in a lot of effort, even for simple tasks, and it might require a full working knowledge of the entire system. But we can't blame change or new feature requests. They are part of software development. We can't stop them or refuse them either. So who is the culprit here? It is the design of the application. The following are the design flaws that cause damage to software, mostly. 1. Putting more stress on classes by assigning more responsibilities to them. A lot of functionality not related to a class. 2. Forcing the classes to depend on each other. If classes depend on each other, in other words, tightly coupled, then a change in one will affect the other. 3. Spreading duplicate code in the system/application. Solution: 1. Choosing the correct architecture. 2. Following design principles. 3. Choosing the correct design patterns to build the software based on its specifications. We go through the design principles first and we'll cover the rest soon.